Welcome to Walkabout the Galaxy, the MegaCon astronomy podcast, where the science is universal, the opinions are personal, and the hosts are available for free celebrity photos and autographs. We are Strange, Charm, and Up, the Astroquarks, also known as Josh Caldwell,
Addie Dove,
and Hannah Sargent.
Coming to you from MegaCon 2022 in Orlando, Florida. Top Quark Jim Cooney isn't with us today because he thinks his newborn baby quark is actually Baby Yoda. We are delighted to be joined by WMFE space reporter Brendan Byrne and host of the show, Are We There Yet? Brendan, it's great to have you with us again.
Great to be here, too, and I'm happy to be the least smart person on this panel. So,
Are We There Yet airs on 90.7 in Central Florida, and the podcast, like Walkabout, is available everywhere podcasts are found, including your smart speakers. We start the show with a devious stumper that Addie usually takes far too seriously. Our stumper today is related to our first two science topics, the Event Horizon Telescope and the James Webb Space Telescope, which see light that we cannot see with our eyes. And since we're at MegaCon and we may see Superman strolling around the halls of MegaCon, one of Superman's superpowers is X-ray vision, although I have a nit to pick about Superman's X-ray vision. So your stumper is, if you could have the superpower to see in some other band of light, some other wavelength than visible light, which would you choose? And I'm gonna give it to you with specific options.
All right.
Okay, so your choices are X-ray,
Okay.
like Superman, although again I have a nit to pick.
Yeah.
Ultraviolet.
Okay.
Infrared, I broke it into two. Near to mid IR,
Oh,
so
man.
like 1 to 15
So specific.
microns. That means things that are radiating from a temperature of about a few hundred Kelvin. Okay.
Hot things.
Far infrared,
Cooler things.
right. Millimeter wave.
Much cooler things.
You can think about the creepy airport scanners that see through
yeah.
your clothes for millimeter wave or radio waves.
Okay.
So, I have been described as a lizard because
Ooh.
I am cold and I need heat at all times. So, if I could have some thermal infrared imaging and just find all the hot spaces.
Nice.
That's a good
Go and,
reason.
So you're going to be looking at the near to mid IR, so you can scan the room, you can see that wall is hot, and you can run over there and
yeah, just
huddle
to,
up next to it.
warm up my hands a little bit. But
I
then
see.
if I was talking scientifically, which I'm supposed to be doing,
Okay.
I would probably...
It's up to you.
Well, yeah, I have to bring in the moon at some point.
Sure.
And searching for water on the moon, we need to look at the absorption of certain wavelengths of light. And that would be around like 1 to 3 microns. And that tells us that we've found water. So that would
Okay.
be really cool.
Well, that's still going to work. Your near to mid IR range works from 1 to 15 microns. So you can see your hot spots to warm yourself up, and you can also
Do my science.
do naked eye spectroscopy of the surface of the moon, which
But
is pretty good.
But also, it's always good to just be able to find water on Earth too. So
Oh yeah, if you're
if you're
thirsty,
thirsty all the time.
just turn on your water
My
vision.
regular visible
It does
vision
much
is
better
working
for
pretty
that,
well
yeah.
for that. Addie, what about you?
I don't know. So I
She
think
takes it far too
I do
seriously,
take
as
it far
I've
too
said.
seriously.
Yeah.
I think that it would be pretty interesting on Earth to have UV because I don't know.
You
It's
can
just-
see some
it's
pretty
just-
beautiful things
The problem
in
with
UV.
UV is that the Earth's atmosphere blocks so much
Yeah,
UV that
which is why
we
on
don't have
Earth
a
it would
lot of
be-
UV photons.
But that's why it
flying
would be
around.
really cool on Earth because you'd be like, oh, there's not going to be as. Plus, if you do all of the other ones on Earth, you're always going to be bombarded with
Right.
stimulus.
Okay. Brendan,
UV would be like, oh, there's a cool thing over there.
what do you think, Brendan?
I'm contractually obligated to say radio waves, obviously,
Yes.
as the
Okay.
radio guy, and also because I want to see where my show goes.
You wanna see-
I want to know who else is
You
listening
can
to
actually be able to see your show.
Yeah.
Yeah. Well, my nit to
love it.
pick about Superman is his so-called X-ray vision is really millimeter wave vision,
It is.
right?
Yeah.
It lets him see through clothes or thin barriers, but if you're able to see X-rays, you're not going to see anything.
Mhm.
Yeah.
If there aren't any X-rays flying around
Yeah.
down here,
I have to say, it's so much fun to talk comic books with scientists because you guys really.
we ruin it for you.
You ruin everything,
Yes,
yeah.
I'm sorry. Very sorry about that.
Physical.
Yeah. Well, today we'll talk about two amazing telescopes, the Event Horizon Telescope and the James Webb Space Telescope, which Hannah prefers to call,
JWST.
and,
JWST.
and some new insights from Mars Insight. But first, this episode of Walkabout the Galaxy is brought to you by Saggitarius A. You've seen the pictures and read the stories. But to really know the gentle giant at the heart of the Milky Way, you've got to see the relativistic jets and accretion disk of Sagittarius A star for yourself. At only 27,000 light years from Sol, Sagittarius A star features a modestly supermassive black hole producing a dazzling network of radio emissions and high-energy photons to light up your vacation, whatever your preferred wavelength of observation. So get off your A star and come on down to Sagittarius A star. Sagittarius A star, a journey that begins where everything ends.
Oh, that was
Oh.
good.
So a journey that begins where everything ends. A tagline from.
Yes.
I don't
It's
even
relevant
recognize
to
that.
where we are here at MegaCon. A journey that begins where everything ends. Where does everything end, cosmologically speaking?
Disneyland.
It's Orlando. It's Disney World.
Disney World. Sorry, I'm from Europe.
Yeah.
Where does everything end?
Where's everything end? A journey that begins where everything ends. Anybody in our
Anybody know that?
group knows that. It's the movie, The Black Hole.
Oh, I was never gonna get that.
Yes,
Yeah.
from
Sorry.
1979.
Somebody in the audience
Yes,
got it.
yes. And it's appropriate for Sagittarius A star, which
Yes.
is the site of a supermassive black hole at the center of our galaxy.
A moderately supermassive black hole.
Moderate.
As you
It is
described
moderately
Yes.
supermassive
It
black
was
hole.
described as a gentle giant.
Yes.
It was.
Gentle giant.
Are you
Yes.
less afraid of it?
No, absolutely
Okay.
not. No.
Still terrified.
Terrifies the crap
Well-
out of me.
Well, before we talk about the EHT, let's talk about some space events closer to home.
Yeah. There was just last night we had the Starliner, the Boeing spacecraft, the Starliner docked with the International Space Station.
Good.
I saw a lot
Finally.
yeah, there was a lot of finally this happened in articles about it, which is because it was supposed to happen about 2 years ago, and there
2019,
have been
yeah.
a few issues. First, it was software on the first flight, and
Software, thrusters,
Valves.
valves,
I
all,
mean,
all sorts of. Space is hard, right?
Yeah, and I love that they've still called it a success, even though there were multiple like thruster failures on the way up. But there was so much redundancy,
Right.
they still got there.
Yes.
But I still wouldn't want a ticket on top of it just yet.
Oh, I
You're
would.
not- you're
I
not
would.
signing up?
Yeah.
Brendan, you're ready to go
Oh,
on
yeah.
Starliner?
I'd
Yeah,
go.
I'll take any ride at this point.
Yeah.
Yeah.
So now we have two commercial crew capsules docked at the space station at the same time, right?
It's pretty
now.
wild.
Yeah.
There's Starliner. There's SpaceX's Crew Dragon. There's also a Cygnus up there. There's another Russian supply vehicle, and Northrop Grumman's supply vehicle is docked to the station.
is there
Very
a,
busy time. It's
is
like
there
the
a
parking
Soyuz?
lot here.
There's got to be a Soyuz.
There's Soyuz
also.
there, yeah.
yeah.
Right.
It's a good
Yeah.
thing they have all those ports now.
Yes. Yeah.
Yeah. So, yeah, finally, good to see that off the ground. And in principle, their next flight of the Starliner will have astronauts on board.
Yes.
As early as the end of this year. Could happen by the end of the year.
That
Right.
would be exciting.
That would be super exciting.
I I'd be watching through my fingers.
I know.
That would
Yeah.
be intense.
Yeah.
Hopefully, we'll be able to go out to it.
Well, I think redundancy is the key with human spaceflight, and I would go. I don't know how much money I'd put on actually successfully docking with the
Yeah.
space station, but
You get a great view.
surviving the
Yeah.
ride,
Yeah.
I think, is a good bet. And then, of course, tomorrow, Brendan will be speaking with you about Artemis
That's
and
right. Yeah.
human spaceflight in general. So the Artemis flight is now not this year,
It depends on who you ask.
but not with definitely
on who
not
you
with
ask.
people.
Definitely not with
Yeah.
people this year.
Yeah.
But yeah, well, we should have a dress rehearsal next month, and possibly a launch this summer.
Right.
Maybe.
So,
Yay.
so the dress rehearsal famously didn't go off quite as planned.
It didn't. No.
But that's what
Either.
dress rehearsals are for.
Right.
Yeah.
Right.
Glass half full when it comes to rocket tank is not a good thing. So yeah,
Yeah.
they were only able to tank it about a third of the way, which is
Yeah.
not good. Not good,
Right.
So.
You can get a third of the way up. That's not how physics works.
That's not how it works
That's
at
not how
all.
physics works.
Well, a third of the way up wouldn't be a very good place to finish your flight.
No.
So the big news, of course, in the last week has been the announcement from the Event Horizon Telescope Consortium. So the image here is showing the Event Horizon Telescope, which isn't actually a telescope. It's a collection of telescopes
The image Josh is showing right now is a picture of the Earth with some dots on
with
it.
some dots
Yes.
that are scattered all over the Earth, from the South Pole to Greenland and Hawaii to Europe. And these are millimeter wave, which was, did nobody pick millimeter?
Nobody
We have
picked
radio and
Yeah.
Yeah.
what did you end up picking, by the
I
way?
said UV.
UV.
You should
So-
love that answer.
Yes, I'm a UV guy. So these are millimeter wave radio telescopes, so
Yes.
very short wavelength radio waves, Brendan. And The amazing
I
thing
can't
about
see
this
them.
telescope, there's sort of two things that matter with telescopes, right? One is how much light can you collect? So when we think about amazing pictures and things from like Hubble and JWST, which we'll be getting to in a minute, there's a big mirror that's just a giant light bucket. It's collecting a whole bunch of light so that dim things, we can build up a nice picture and see these very faint, very distant things nicely.
Yeah, collects all those photons.
The other critical element for a telescope is its resolution, which is how small a thing can it see.
Yeah.
And that that depends on the size of the telescope, but it doesn't depend on how many photons it collects. It depends on the diameter of it.
Yeah.
So the EHT combines a bunch of little telescopes. They're not
They're not
that
that
little,
small.
right? They're tens of meters across.
Yeah, millimeter
right?
and radio wave telescopes have to be bigger.
They're big, right? But it combines them all around the Earth so that the telescope is effectively the size of the planet.
Yeah.
But they all have to be operating at precisely the same time,
This
which
is-
is a marvel in itself.
Yeah.
This is the technologically mind-blowing part of this thing
Mhm.
because they have to use atomic clocks to time when they're receiving the signals from whatever it is they're looking at so that all those signals from all those different telescopes can be combined in the right way to produce a single image as though it were a single telescope the size
They
of the
essentially
planet.
turned the planet into a telescope, which
Yeah.
is
Right.
absolutely bonkers. That's
Yeah.
so
Right.
cool.
And so a telescope the size of the planet is needed to see something as small as the moderately
sized black hole, supermassive black hole, at
Which
the
would
center
still
of
mess
our
up your
galaxy.
day. It would still mess up your day.
It
if
would,
you, yes.
If you got
Unlike-
too close.
The equivalent resolution they said was looking at a donut on the moon, right?
Yes.
Right,
Just to give you an idea of.
Just in
right,
How
case you weren't
ridiculous.
already hungry.
right. And
From
it,
Earth, looking at a donut.
Yeah.
on the moon.
it,
Yeah.
it looks like a donut because around that
Ooh, a
black
science
hole there's
graphic.
no light escaping from the black hole itself, but around it there's a lot of stuff swirling around, and it gets heated up by friction and accelerated by magnetic field. So you have this hot glowing disk
Yeah.
or accretion disk around the black hole.
So the important thing about a black hole is that it's a black hole. We're never going to actually see
Inside
the
it.
inside of the black hole, right? So there's these amazing new images from EHT, which we'll show maybe sometime. I think next slide maybe. But there's these amazing new images from
Yes,
EHT
we will show.
that are that are the shadow of the black hole. So you see that sort of black hole area in the center, but you see all this gas that's super hot accelerating around it in this image. And then, but the image is actually this composite image. So like, it's actually getting light from around it in the disk and behind it and the side of it, and it's really crazy how they like combine the
It's like
light.
Tens of thousands of images they took
Yeah.
Right.
to composite them together.
The amount of data is also astonishing. It's like there's the timing that has to be done.
hmm
Then there's the quantity of data that has to be physically co-located,
It's like, what,
And I-
2.5 petabytes, I think it was?
Yeah.
Which is
a giant.
crazy amount.
Right.
Yeah.
That's 2.5 million gigabytes.
Yeah. It's like 100 million TikTok videos is what my math was able to figure out.
Okay.
Yeah, and it's
So that's
literally
like-
stored on like shelves.
Yeah.
Because there's just so
they
much.
can't transmit.
Yes,
Yeah.
these things
Physical
were
hard
not
drives.
emailed. These data were not emailed. They
No.
were physically carried.
Put on
Can't use-
planes and taken to different places to
Right.
process.
Yeah.
It's wild.
Right. And you mentioned the donut and people using this donut, and you said we'll always see this donut because even though the disk, you say, well, if I'm looking at the disk edge on, but the light from behind the black hole that's going up and not towards your eye gets bent by the gravity of the black hole
You
towards
still see it.
you.
Yeah.
It gets bent in all different directions, but no matter where you are looking at a black hole, you will always see a ring. You will see that accretion disk ring
Yeah.
because it is the gravity is so strong that it is
Folds
bending light
light.
in every
Josh,
different
what's
direction.
an accretion disk?
An accretion disk, are you actually asking?
Yeah.
Yeah.
That is the disk of material around a central massive object that is falling into that object. Now, I know Brendan has an unnatural fear of black holes.
It's not
And-
unnatural.
They're pretty scary.
It is. It's maybe an excessive fear of black holes.
Excessive. I'll give you
Excessive is
excessive.
good, yeah.
Their black holes are not vacuum cleaners. There's nothing magical about their gravity in terms of like making things fall to them any
Mhm.
more than anything else that's got gravity makes something fall. The reason stuff spirals in an accretion disk into the black hole is because of energy loss processes in that disk.
Mm-hmm.
If you just put a single object in orbit around a black hole,
Like me in
Yeah.
Starliner.
like you,
Oh yeah.
in the Starliner,
Starliner. I like
That
it.
would be an unfortunate.
at a
It happens to
reasonable
defense, but
reasonable distance,
Does it have its thrusters?
all the thrusters working,
Okay.
you could just coast the way the Earth has been coasting around the sun for 4.5
Mhm.
billion years.
Mhm.
But if you have a dense disk of material, there's friction, and that friction produces energy which gets radiated away, and that energy comes from the orbit. So those orbiting things then fall into that central
Yeah.
object.
So as long as you don't run into anything and have
We'll be
or
good.
have friction, you'll be fine.
Okay.
Yeah.
And we're going to see accretion disks when we talk about JWST also,
Oh, cool.
because it
Yeah.
looks at different sorts of accretion disks. But this is the
So
image.
what a good question, Brendan, right?
That was a
Excellent.
great question.
Well done. You should maybe go into questioning people
should.
for a living.
Make this my job.
Yes,
yeah.
So I was a little bit underwhelmed by the image released by the Event Horizon telescope of Sagittarius A star. A couple years ago, they released the image of the not moderately, but
No.
truly amazingly
Ultra
supermassive.
supermassive black hole.
Right, in
Yeah.
M87, a nearby galaxy, and it's much bigger, so they were able to see that.
And
This
they
thing
imaged
is
that
tiny.
one. They imaged that one first because it's much bigger, even though it's farther away.
Right.
It's a bigger thing. It's much bigger, and when we're looking out, sort of away from our galaxy, the sky is clearer, basically.
Right.
But when we're looking toward the center of our galaxy, we have to look through all the crap, all the
Mhm.
dust and gas that
Yeah.
goes in between us and the center of the galaxy. So this black hole, even though it's closer at the center of our galaxy, is just harder to image.
Much harder to image.
Wasn't Sag A star spinning faster than
So it's
M87 as
because
well?
of its size, yeah, all the stuff moves around it really quickly.
Mm.
So that gives you a blurring because you're
Yeah.
taking these images from all these different telescopes scattered around the planet.
But
So
one of
this-
the actual exciting things about imaging these two different black holes, which are so different in scale, is that they still have really similar properties. So it's confirming that like this physics translates across these massive scales.
Yeah.
Right.
Yeah.
So
Einstein does it again.
Einstein does it
Einstein.
again.
You
He's still
physicists
going.
were right.
Yeah.
One
so
thing that was crazy about this image, and they released the image, and there's not been a lot of like the scientific papers that have come out yet about it. But so it's an average of over time because everything moves so fast. They had to sort of average it, but it has these blobs in certain areas, and I haven't seen an explanation for that yet. And I'm really curious if that's like where more light is focusing because of the shape of the accretion disk. If it has to do with like just how they're averaging the images. So I think that there's still going to be some really interesting results coming out.
yeah, if we place that thing in context of everything else that's going on in the center of the Milky Way, there's all sorts of dramatic things going on in there. Brendan, you mentioned it's spinning. It's got a magnetic field. The accretion disk has structure, as Addie was mentioning, that we see hints of in that picture. And then this dark spot in the middle is the
shadow of
the
the
sh-
black
the
hole.
shadow. Yeah,
I do love that description.
that's a great
Mhm.
great name for a movie.
It would be a great movie title.
Yeah. Well, it's now time for Walkabout Trivia Interlude.
This is my least favorite part of
Oh,
being
me,
on this
me
show.
too.
Really? Really?
I mean,
Well-
it's okay to get it
I'm
wrong.
always wrong.
Well, since
Welcome to the show.
since we're at MegaCon, finally, we've been talking about a lot of finallys. Later this year, finally, the sequel to Avatar.
Oh, I thought you were going to
is
say the
coming
sequel
out.
to Top Gun.
Yeah. And the events, so I have several, as you know, that's a multi-part trivia.
As usual.
The events of Avatar, James Cameron's film from 2009, we have a
Not the
sequel
Last
coming
Airbender.
out, Avatar, The Way of Water, in December of this year.
Also not the last Airbender.
No, right. They take place on a moon called Pandora, orbiting a fictional planet around a real star. What is that star? And here are your choices. We have some fun science fiction-y choices in there.
Sagittarius A star.
Don't answer now.
Oh,
Don't shout out your answer. We're
That's
holding
not
our
one of the
answers.
options.
You get
Yeah.
to ponder this. And it's not Sagittarius. Sagittarius A star is not a star. Yeah.
A
well then
star.
why do they call it a
So-
star?
So your choices are Alpha Centauri, Vega, Sirius, Tau Ceti, or Wolf 359. Addie is biting her lips with a pleased expression, so she may know the answer to this one.
I know one of them that it isn't, purely because it's from another film.
Okay. The second part also relates to the moon Pandora. It's a
Okay.
moon around the fictional planet around the real star. But there is a moon in our solar system called Pandora.
Oh boy.
It's orbiting one of the 5 planets that you see here: Jupiter, Saturn, Uranus, Neptune, or Pluto. And yes, I just called Pluto a planet.
We will continue to do that.
Yeah, look at it. Looks like a planet. Sorry. So the second part of your trivia is, which planet does the moon Pandora orbit in our solar system?
Don't mess this up.
Okay.
Oh,
We'll come back
no.
to that for your answers after our next 2 science topics, and with some follow-up
So I can look up the.
additional.
no
I have.
internet
Here actually I have the third.
Oh God.
The third, Kate Winslet, who I have a special relationship with, set a record for duration of breath held underwater while filming a scene for Avatar: The Way of Water. For how long, how many minutes did she hold her breath to film this scene, and whose underwater movie breath-holding record did she break? Okay, so you got a whole bunch of Avatar
I'm
trivia.
never doing this
Questions.
show again.
You
so
can
much
just,
work.
You could just
Come
opt.
on.
You could just opt out of
I'm
the
gonna
trivia
opt out of
segment.
trivia.
This is trivia.
90% of my experience on this show is guessing answers to
Yeah.
the trivia,
you're
and I'm
usually
supposed
very
to know
good at it.
things.
I'm guessing
No,
all
you're
the
not
very good at
supposed
it.
to know them.
Okay, well, let's talk about JWST, or as Hannah likes to call it.
JWST.
Okay,
JWST.
which is finished its focusing and instrument alignment and calibration.
Finally.
Finally.
Actually, JW did
It's
take a
pretty-
long time to launch. So, but once it got up there, everything's been proceeding as planned. It's been making like a remarkable timeline. It's an amazing new telescope.
It is, and it is its own individual telescope. It's not doing any of the fancy, complicated stuff EHT is doing,
And it's in space.
but it's doing its own unique, fancy, complicated things.
Yeah.
And it's looking in Hannah's favorite part of the spectrum, in part, the part that Hannah would use her superpower for.
It's looking across loads of, like, such a broad spectrum, actually.
It's the near to mid IR and into the far infrared. So
Yeah,
what? So
all the IRs.
yeah. Why are the IRs good again?
Because I just love the fact that it can look at everything from not just outer solar system, distant galaxies and everything, but it's going to be used to look within our solar system and taking spectra of like the
Like
gases
asteroids.
on our planets and different asteroids. Actually, there was a really cool story with JWST that it just made me laugh, because they've been like calibrating the telescope, and one of the things they have to be able to do is track moving objects, including asteroids within our solar system. So when they were choosing an asteroid to practice on, there were plenty, and a lot of them are very similar.
There's several asteroids.
There's a few, I've
Yeah.
heard. And when they had to choose one, they couldn't
Two
really...
of them named after
Yours too.
Yes.
Maddie and me, by the way.
Unfortunately, yours wasn't chosen, but they chose one called Tenzing Norgay, the famous Tibetan mountain guide, who was one of the first people to reach the summit of Mount Everest.
Aw.
And because they're all virtually identical, they chose this one because the quote is, the name was linked to success, so it seemed like a no-brainer.
What? Our names
Our
aren't
names
linked
are
to
also
success?
sorry, sorry, you're underachievers.
Did they
Maybe
get
we
to the
weren't in the
summit
right
of Mount
part of the
Everest
sky
on
at the
time?
time.
I don't know.
That's the important thing.
Yeah, I'm gonna have to do some research.
Well, I mean, you mentioned the right part of the sky, and one of the amazing things about JWST is that it, as Hannah was saying, it can look at everything, and you were sort of referring to every different kind of thing in the universe, but it can also look everywhere in the universe because it's out at the Lagrange point. One of the Lagrange points of the Earth has this big solar thermal shield, and it orbits the sun with the Earth. And so over the course of a year, it has access to everything in the sky.
Yeah, a lot of telescopes we put into space orbit the Earth, and so at certain times they're close enough that at certain times, like the Earth blocks
The Earth
the
is
view.
in the way, can't
Um,
look towards the sun.
But if it's at one of these special gravitational sort of safe points, it can just hang out there, orbiting at the same time as the Earth, and the Earth is very small in its field of view if it gets into the field of view compared to.
It's beyond, so it'll never be.
It'll never be
always
in the
be
field of
looking
view?
away.
Oh,
yeah,
okay,
yeah,
nice.
Yep. Go ahead,
I was going
Hannah.
to say, one of the other things that I thought was really cool about JWST was that it has an array of 250,000 miniature movable windows that are all individually controllable.
Yeah.
It says 0.1 by 0.2 millimeters in size, and just the fact that it all works blows my mind.
Right.
Yeah, a lot had to go right on this mission, and it did. It's
did.
It's pretty wild. It's
Yeah.
Pretty wild.
And
Yeah, we started with, when they first launched, they started sending back images, and they were sort of these blurry things, and the stars weren't all lined up, but they kept publishing images, and it got more aligned and more focused. It's very exciting.
And like EHT, those special technologies that it's using to produce the sharpest picture it possibly can for a telescope of this size. So the diffraction limit that enables us to see the donut on the moon with the EHT or the Saggitarius A star event horizon, that is a fundamental, and you can't do anything about that. Even to get to the diffraction limit, though, requires extraordinary measures, and JWST is going to be taking these super sharp pictures.
Where can JWST see donuts?
Where can JWST see donuts?
Can it see a donut on an asteroid?
Well, it can see donuts around other stars.
Oh, I
It's
didn't even mean to make
almost
that
like
a
we
segue.
planned that, but it was a complete accident.
Yay.
So, Brendan, you asked about accretion disks, and we have accretion disks not just around supermassive black holes, but also around stars. When stars form, they're accreting. And planets are the leftover bits in what used to be an accretion disk around a star. So our whole world here is just this tiny little bit of leftover mess from the IKEA assembly project of the solar system. It's one of the leftover pegs or screws or
Really
Yeah.
puts it
Things
into
like
perspective,
that.
doesn't it? We're
Right.
just a little leftover screw of the IKEA of the universe.
So 4.5 billion years
you have a way with
ago,
words, Josh.
there was a disk of gas and dust collapsing around the sun, and a lot of that material was feeding into the sun. And fortunately for us, some of it
Clumped.
formed into
It
planets.
clumped together,
It clumped.
and then we came around.
Right.
Can I tell you why I'm so excited about
Yes,
James
please
Webb?
do.
Okay, I'm excited for two different reasons. One, I'm super fascinated with exoplanets
Uh-huh.
Yes.
and the fact that this telescope could possibly see what these atmospheres of these planets outside our solar system are made of. Just mind-blowing.
Yeah.
But from a public perspective, like, I'm sure you scientists are super excited about this.
We scientists.
But yes, you scientists. But the images that we're going to get from this thing are going to be like Hubble to the public. Like, remember when those first images came back from Hubble, and some of the most iconic images of space
Right.
come from these space-based telescopes. So I cannot wait
Yeah.
to see these images and what it inspires of us lay people down here on Earth to see it. So I'm super excited for that.
Yay.
And
Yeah.
because it's looking at a different part of the wavelength than Hubble, we're going to be looking at different things
Yeah.
with that super sharp
But
imagery.
still just as dramatic and impressive
yeah.
when it comes to seeing it. Like the Pillars of Creation is still like my favorite,
Yeah.
Right.
astronomical image, and we're gonna have that times 1,000
And
when
Hubble-
when JWST comes online.
Yeah, and Hubble has stayed around for a lot longer than we expected, and they'll be able to do some of the same imaging with Hubble and at JWST
It's
and
gonna be
see
really
how
cool,
those images
yeah.
match. So it'll be really cool.
Right.
Yeah.
So, yeah, the accretion disks are something that, like Hubble saw the cool dust clouds around stars and things like that, JWST will be able to see the heat from those frictional
That's
rubbing
wild.
disks
That's
around
wild.
these stars in unprecedented detail.
Yeah.
So we're going to be seeing things like the formation of our solar system 4.5 billion years ago around other stars.
And then we'll be seeing the planets that result
Yeah.
from that, and hopefully be able to actually resolve the atmospheres of the planets, as you said.
Yeah.
I think, and it's really interesting, like to your point, Hannah, of like what the telescope has to be able to do in terms of like being able to see things that are really far away and resolving them versus like how it has to react to things that are in our solar system and moving quickly. Like they're very different types of observations.
Yeah, and I'm interested to see how all these different scientists kind of combine their data because so often, even when telescopes end of mission, their data is still being processed years gone by. So we've got all of this potential science already that is planned
Right.
from planetary scientists, exoplanet searches, looking for the earliest stars in the universe, and then who knows what else this data will be used for in the future. I just feel like this is just an incredible source of scientific data.
And it's a super cool looking telescope.
It's
Yeah.
huge too. Like
It's
you cannot
huge.
underscore how like
It had to be
that sun shield.
unfolded,
Yeah.
The
right?
sun shield's the size of a tennis court.
Right.
I mean, this thing is massive.
Yeah.
It's two amazing technological
Yeah,
achievements
that was
in telescope.
folded and, yeah.
One of the things that we've talked a lot about sort of exoplanets, and it will be able to, as you mentioned, Brendan, maybe see what's in the atmospheres of some of these planets. But it'll also be looking at the early universe,
yeah?
and the infrared is necessary for those early universe images because of one of my favorite cool physicsy things, which is that
Redshift.
the expansion of the universe means that light that was produced in the early universe has been stretched into longer wavelengths and therefore redder colors
Everything gets a little stretched out as you get older.
as you get older.
I'm
Tell
actually
me
really
about it.
excited about this property because when I was reading up on it, they were saying that they want to be able to search for and understand how metallic. This is the astronomer's
Yes,
term.
yes.
So anything that isn't hydrogen and helium, right?
Right. Yeah.
And so they wanted to be able to look at, I think it's the oxygen lines, and so
Which
the-
are normally in the visible or UV.
Yeah, and so it shouldn't be able to, the JWST shouldn't be able to detect these lines that will tell us how metal rich these stars are, and therefore how fresh or how old these stars are.
Right.
But
They have as the wrong supervision in principle.
But then because the stars have been moving away from us so quickly over such a long period of time, that light has been stretched to the point where JWST can actually detect it.
Right.
So
It's moved from the ultraviolet into the infrared
yeah,
From me to
due
you.
to the literal stretching of
Yeah.
of space-time.
by moving further away, we can see it better with JWST, which is a
Yeah.
mad idea.
That's cool.
Yeah.
And there's a related phenomena with EHT and the black hole at the center of the galaxy, which is that very strong gravity also stretches
Yeah.
wavelengths of light out. It's called a gravitational redshift instead of a
type of
cosmological redshift, so that the millimeter wave, even longer wavelength telescope of the EHT are able to see emissions that, at their heart, some of them are at shorter wavelengths.
Redshift.
Cool stuff.
Redshifts all around.
All right. Well, we're going to
Okay.
bring it a little bit closer to home
To
for
the
our
red
final
planet.
topic.
Oh,
Very
good job.
good.
Good job.
Yes, the Mars Insight lander. So there's fun news and sad news.
Yeah, we're talking about EHT and JWST, which are new telescopes. But InSight is sort of maybe toward the end of its life. So InSight was the Mars lander that's a geophysical suite. So it's supposed to be able to detect Mars quakes. It had a probe that was
didn't-
supposed to
not so
detect
much,
heat inside,
right.
but it had some issues with its probe.
Underperformed.
The mole,
Yeah,
the
the
mole was
mole.
supposed to go down 15 feet, and it went down about 6 inches.
yeah, 15
15
centimeters.
centimeters, right?
But the seismometers performed remarkably well, and the seismometer is a thing that sits on the surface and it's trying to detect Mars quakes. It has this dome over it that's a wind and thermal shield, so it can but it has little instruments on it too, so it knows when it's windy and what the temperature and the air pressure are like. But so the seismometers worked really well over the course of the mission. They've detected around 1,300 Mars quakes, which is remarkable because we thought that we'd be able to detect some, but we had never done it before on Mars, so we'd never detected Mars quakes before.
I have a question.
Go.
I know this because we just talked about this. If there's no plate tectonics on Mars, like there are here on Earth,
Yeah.
which cause earthquakes here,
Yeah.
what are causing Mars quakes?
That is a great question that I
Thank
don't
you.
have an answer to. Oh, yeah. So on Earth, most of our earthquakes come from the fact that we have like plates that are shifting, right? So they rub against each other, they go under each other, and that causes earthquakes. But on Mars, everything's just sort of like a one solid thing for the most part. So we don't actually know exactly the sources of all the quakes. Some of them are probably due to impacts. So Mars has a pretty thin atmosphere, so it still gets its surface bombarded like our moon does. A little bit more than on the Earth. So some are probably due to impacts. Some might be due to some of these chasm regions where there's like cracks and fissures in Mars, and there might be a little bit of residual heat and motion there. Or you had mentioned, I think, Hannah, that maybe like Olympus Mons and some of the volcanic regions might also have some residual heat that are
Yeah, even though there's no
shifting a little.
tectonics, there still might just be some creaking and cooling and
Something
things
Thermal-
going on.
underneath,
Yeah.
right?
Yeah, thermal stresses can cause things to. Sometimes you hear that, and your furnace might pop or something when it
we
comes
live in
on.
Florida.
things
we don't have furnaces.
heat up. I'm
What's a
still
furnace,
remembering.
Josh?
I know. I'm remembering my Colorado days. But the moon has thermal quakes. Moon quakes are caused by heating and cooling, which causes things to sort of pop a little bit, produces a little quake. But we saw the biggest Mars quake ever.
Yeah, so InSight is slowly shutting down because it's getting dark there. And by getting dark, we mean getting covered with dust, and the
Yeah.
atmosphere is getting full of dust. But it actually just recently detected one of the largest Mars quakes. It's detected. It gave us like a final big
A
present,
last
maybe.
hurrah.
Yeah.
How big
it's
was it
a
on the Richter scale?
Magnitude 5, which
Okay.
is like
pretty
a
big,
decent
right?
size.
You would notice it
earthquake.
if you were there.
Yeah, yeah.
Was
And
that,
they don't-
was that an earthquake?
You'd be like,
You
no,
said
it was
no.
a Mars quake.
Exactly.
But I love this story about that the solar panels are getting covered in dust because when I was reading about it, they were describing the landing site as if they were super delighted that they landed in this mostly dusty terrain with very few rocks, but they didn't really explain,
Because that's good for the instruments.
it's good for the instruments to an extent, but that landing site was also in the bottom of a crater, which isn't great because one of the mechanisms of getting rid of dust that collect on your solar panels on Mars is with these whirlwinds and these little
Dust
these
devils.
little dust devils, and they've been clearing dust off Mars rovers for a number of different missions, and they were hoping to do that here, but because they're in the bottom of this shallow crater,
It's calm air.
it's relatively calm, and so they're just like, come on, we need a gentle breeze, and
Yeah.
nothing's happening.
Yeah.
So the dust has definitely been collecting more than they had.
And that's the
expected.
sad part of the story because they're anticipating the end of the mission is near.
Imminent.
imminent.
Yeah.
It'll slowly lose power and shut down because there's more dust in the atmosphere right now. Mars goes through cycles where there's more dust in the atmosphere. And as you said, it's just not really clearing off. Although they did do a couple of tricks. Really quickly,
yeah.
we'll say they did this cool trick where they were like, okay, we're not getting these dust devils to come by and clean off the solar panels. So they actually put more dust on a part of the solar panel.
With
They
their
put-
little scoop,
they-
right?
How did they put?
They have that little arm that they use, the claw that they use to
They
like put
grabbed
things
dust
down.
off the
They
surface
scooped
and
dust
dropped it on their
and-
own solar
yes.
panels.
They were like, this is a great plan.
Okay.
But
They obviously ran out of ideas.
yeah, like I don't know, put
Let's
more
try
dust
this
on.
one.
Maybe it'll. No, but
It worked, right?
It did.
It worked
'cause
for a
there
bit,
was
yeah.
enough on like one edge that sort of blew across and scraped some of the other dust off.
Use
Like
the
the
big
weight of
pile
it?
of dust
Yeah.
to make the rest of it go. You
Yeah.
didn't have enough cross section, I guess, when there's a thin layer.
Yeah,
So you put a
because
big
the
thing-
thin stuff is going to be harder
That's
to move
wild.
than just like
They should have
bigger
just put a
stuff that
piece
they-
of plutonium in it like the other Mars rovers, and it would have been
Oh,
on
yeah.
there
Yeah.
forever,
And then it'd
right?
be nice and warm
Yeah.
too.
Yeah. All right. Well, it's time to see how good you are on your Avatar trivia.
Okay.
So,
I feel like all of the people who love these great films are going to be really upset with us.
no.
That'll
So
be
your
fine.
your first question was, what is the star system that Avatar takes place in? Is it Alpha Centauri, Vega, Sirius, Tau Ceti, or Wolf 359? And we'll start with Hannah.
Oh. Nah.
I was hoping they'd start with Addie, and I was going to steal her
Yeah.
answer.
I don't know the answer.
I want to go with one of the last two. I'm going to go the Wolf.
Wolf 359. Okay. Brendan.
I'm going serious.
Sirius.
I'm going to go Tau Ceti.
Tau Ceti. So we've got Sirius, Sirius Black, Harry Potter, Wolf 359, of course.
Star Trek.
Star Trek. The answer is
Damn.
Alpha Centauri.
Really?
Oh, okay.
Really?
See, I was going to
Yeah.
say
Too
that, but it
easy.
seemed too
Oh,
easy.
sure.
It does make
Oh,
sense.
sure. It's easy to
It
say
was
you were
one
going
of
to
the
say
other
that.
four.
Yeah. What real planet in our solar system has a moon called Pandora?
Uranus.
Saturn.
Neptune?
It is Saturn. Okay.
Ah.
One correct answer.
That,
How many
Out of-
moons does Saturn have? A lot.
So
right?
many.
Over
like
60.
60
Yeah.
something.
Yeah.
Same with Jupiter.
As Jupiter, also a
Yeah.
crazy number. Even Uranus and Neptune have more than,
Saturn's
I think
moon,
more than 20.
Pandora, not a
Mhm.
water
Even
planet.
Pluto has 6 at least. That
We
we
might
know
get a
of.
look at some of those moons of Uranus soon, right?
Oh,
Thanks
yeah.
to the
Oh,
data.
Uranus,
yes.
Uranus mission is in the offing.
Yeah.
If we have to be patient.
Yeah.
Yeah. So the future mission
What,
will be going.
2030, 2040 or
It's
something?
far
A
away.
future MegaCon will be
Yeah.
going finally.
Yes.
Yes. Okay. And
In 7
how
years.
long did Kate Winslet hold her breath for? And whose record did she break?
So my guess is that she broke her own record from Titanic holding her breath
Oh.
underwater.
Wow.
Just kidding. I don't actually guess that.
You
but-
don't actually guess? I like that guess.
Okay.
I
That's
was
my
gonna,
guess
I was
then.
going to say she broke her co-star from the Titanic.
I was going to go
Leo,
Leo as well.
Leo DiCaprio.
Yeah.
I like
Yeah.
both those guesses.
Yeah.
The actual answer is not. Is it? She broke Tom Cruise's record from Mission Impossible
Oh, yeah.
Rogue Nation.
How long was it?
You tell me. That's the trivia.
2.5 minutes.
2 minutes and 15 seconds.
$1.
3 minutes.
Oh, I'm really disappointed in your opinion of Tom Cruise's breath holding ability.
Well, I
Tom
have a lot of
Cruise's
slow
Tom
opinions.
Cruise's number was 6 minutes,
What?
Oh, wow.
and Kate Winslet's 7.
Go Kate.
Wow.
Yeah.
Multi-talented.
Bonus
Wow.
follow-up trivia: Avatar was the top box office earner, but it lost it to what movie?
Deep Impact.
I love that guess. I love that guess. Everybody should buy Deep Impact.
What year was it?
Avatar came out in 2009. It lost its record.
Wasn't it one of the Marvel movies?
Anybody in the
It
audience
lost its
know?
record in 2019 to
Iron Man.
Avengers Endgame.
Endgame.
I'm gonna get.
But then it reclaimed it following a re-release in China in 2021. But in inflation-adjusted dollars, Avatar remains second all-time behind which movie? Gone with the Wind, Star Wars Episode 4, Lawrence of Arabia, The Wizard of Oz, or Titanic?
Well, I want to go to Titanic, even though I
Titanic.
don't think
Yeah.
it's right. But I'm gonna go.
You're all
Titanic.
going to go Titanic?
Yeah.
It's
Sure.
still Gone with the Wind.
All
Oh
right.
wow.
Yes. Yep. Lots of tickets
Yeah.
sold for that.
I think I lost out on every question of the trivia, so I lose my
Yep.
seat as a
I
scientist.
think we're done. We can just split this
You may have
table.
done
and
that. Well, while it may have felt like
Come
holding
work
your
in
breath
journalism.
longer than Kate Winslet, it was just another episode of Walkabout the Galaxy. We're 3/4 of the AstroQuarks and 100% of the world's #1 space reporter.
Aw.
Write us a review on your MegaCon costume and get your picture posted on all the socials. Give us 5 stars and we'll give you the universe. This episode was produced by Chuck Lindsay of truckloadofcomics.com. Our theme music was composed by Richard Drusik. Thanks to our listeners in Orlando, Florida, and around the world. I'm Josh Caldwell.
I'm Addie Dove.
I'm Hannah Sargent.
We're the AstroQuarks signing off until the next episode of Walkabout the Galaxy.